Thank you, Perrin, and I presume everyone can see my screen now. So I'll just jump right into the topic and start the presentation. Then this is the second of the series, of the presentation we're going to make about the technologies, products, and solutions we can offer to the market from Chongmei Technology. And it is still following a similar topic as the first one about ASA material and its application in the building and construction industries. Today, as a topic, title introduced the solution that we are especially focusing on the green building technology. So, right now the sustainability and the green technology is a big topic across the globe, and everyone is talking about it, right? So, and when we are talking about the green technology or green building, behind the word green, there are lots of hints or there are lots of meaning behind the words. Usually, that refers to how we can build the building to save energy, how we can build the building to last longer with less material, with less cost, with less labor investment into set up the building. And while at the same time to allow people to live or use the building more comfortably, more efficiently, to use less money, less resource, less energy consumption to achieve your goal. So that is exactly what we're going to talk about today. Of course, there are lots of different technologies, but we are going to touch one aspect of that technology, which means by using our ASA to make specialty profiles, roofings, and other type of material to help you to build a green building. By to save the energy, to save the cost of building the buildings. Okay, so this is the contents. I introduce myself and then the company briefly. Introduce our products and applications, the major properties of our solutions, and and then we are open. We will open the floor to your questions. Okay, and then let's jump right into the first part of my presentation today. That this is me. If you had seen the first episode of the presentation, you already knew me. So here is the picture, obviously, and I have been working in the polymer industry for nearly 30 years. So I got my education in this area, through my academic life, and then I worked in multiple, international companies, including GE Plastic, Dow, Romas, Poly One. All were, they still are, obviously, the top chemical companies related with the polymer industry. And I am still working in this area by following our own business with Chongmei Technology and trying to offer my knowledge, my experience to our customers and to this industry by helping you building a better solution. Okay, so the company introduction, Chongmei Technology is a small family-owned business founded in 2008. Our headquarters are in a small city called Xinxiang. Xinxiang city in Henan province that is right in the middle of China. We started from 2008 to build a bunch of different solutions related with polymer and offer our solution and products and technology to customers across the nation, in China initially and lately expanded our business globally to many customers in the world, in Southeast Asia, in Africa, in Middle East, or even in Europe. Okay, so and the major products we're making right now are several type of polymers. We listed on the right hand side on this page with ASA, granular films. This is the major topic we're going to discuss today. How we mix ASA, its films, and how we use them in the building and construction industry. And several other high performance polymers like XETFE, ASA PVC compounds, and several other. We didn't include the name on this page, but we make them for the aerospace application and medical care applications as well. So in the following episode, we're going to touch those high performance solutions as well, in the future. Okay, so these are several direct pictures from our operation site. So on the upper left hand, that's our headquarters in Xinjiang, Henan province. On the lower left hand, that's clean room. It's a 100,000 grade clean room we have built to produce the high performance products from Chongmei. On the right hand side, these are two pictures showing our lab and showing the film production line we own within our headquarters and in our manufacturing sites over there. Okay, so this is the major part we are going to touch today. The main products and application we're going to talk about today. So the major products we're going to talk about today are two. The first one is the ASA granule. So basically, it's ASA pellets we produce in our site. We can make them in different size of the pellets. It's a little bit smaller, bigger, or middle-sized of the pellets we can offer to our customer, obviously with different formulations. So we can formulate the ASA into different formulations to fulfill different demands in the market. So if you don't know what ASA is, these three letters represent for the first A represent for acrylonitrile, so that's one of the monomers. The S represent for styrene, and the second A at the end represent for the acrylic, butyl acrylic. So these three monomers, through a complex emulsion polymerization process, we can acquire the resin as a tri-block copolymer, and we call it ASA. And this resin has excellent performance in the weatherability resistance. So basically, it means this resin is very resisting to weathering factors like exposure to UV light, especially with very harsh UV light, to long-term exposure to water, to relatively high temperature and other erosive factors from the natural environment. So which make this resin an excellent choice to make the articles that you want to use outdoor. So and when you want to use it in outdoor environment for a long time, something like 15 years, 20 years, or even 25 years. As you can see from the illustrative pictures we show here, as the tool shell, on the left-hand side, as the camera casing, those articles used on automotive, which are, parked out the door all the time. And on the right-hand side, you can see from the roof tile, this is one of the major topics we're going to talk about today: window profiles, handrails, the board you see in the park, and still ASA composite plate or sheet, as we talked in the first episode of this presentation, and signboard. All these applications on the right-hand side related with the buildings that you need the material to sustain for a long time, and according to the industrial standard in China. The customer usually demands them to sustain the environment for over 20 years. And in many other parts, they would demand the application to last for more than 10, 15, or the same 20 years. Okay, so the second form of the products is we can take the ASA pellets we make. As you can see, we can pre-color the pellets into different colors, and whatever color you like. So these several pictures are the typical colors we sell in China. And in different regions of the world, the local customers would ask for customized colors according to their local aesthetic performance demands, and we can make literally all of the colors you can imagine of on the products, and we can produce the pellets into films. So the product format are a roll of films, as you can see from the pictures, and the benefit of making the products into films are that you can take the film and laminate them onto whatever substrate you would like. And by doing this, we can offer additional benefits or values to our customer, by saving cost. You can simply take the film, laminate them over the substrate and get an article with all the excellent performance from ASA. So again, in episode 1, we talked about the steel plastic composite film, and of course we can make several other plastic films as well if the customer needs it. Okay, and the major products we're going to talk about, the pellets, the films, and the end applications we're going to discuss today, are the roofing tiles. So this is the touching point. We're going to reach the topic of the green building. So there are two families of products we're going to talk about today. This is the first one, the synthetic resin roof tiles. So as you can see from the picture on this slides, that we can take the ASA film or we can take the ASA granules, with two different processes. One is the so-called co-extrusion process, or another one is called the lamination process. We can produce all these synthetic resin roof tiles. The whole roof tiles are made by plastic. Our ASA granule or lamination film sit on the top, and beneath them sitting, with other one or multiple layers of other material, which comprise together with ASA a synthetic resin roof tiles. So, and then you can take the roof tile and then install it on the building and offer a whole bunch of benefits, which we will talk lately in the presentation. And these are the benefits. So in the middle, you can see a scheme. It's an introductive structure of a roof. So when you build the roof, and you would have a base of the roof, right? So the roof base, there is nothing fancy about it. Either it's a fabricated roof, or you can pour the concrete into a box and make the roof. So this layer offers the structural stability and everything comprised of a roof. And then on top of the base, usually you would have the base mat. And the base mat offers noise vibration cancellation, the soundproof kind of functions to resist water, to save energy, so on and so forth. and then the ridge. With the pointed, roofing with the ridge. The ridge is the line combining different facets of the roof, and with this structure to repel waters. And on top of it, there is the tar sheet usually, to offer water resistance, energy saving, and noise cancellation functions of the roof. And on the very top, on the ridge, you can see the orange tiles along the ridge, and all these orange tiles along the surface of the roof is the synthetic resin roof, as we are talking about. So this roof covers the whole surface of the roofing area, and because they are made by plastic, and they can offer a whole bunch of benefits. So they are extremely weatherable, as I mentioned. So they can sustain the roofing usage period for at least 20 years, and usually it lasts for over 25 years. According to China standard in China, and in other regions, at least it would last according to the standard local government standard over 15 years or 20 years. And aesthetic, you can color it to whatever color you like, and you can choose a different color combination to make the building more pleasant, appear more beautiful. Energy saving, water resistance, noise, vibration cancellation are all coming from the plastic nature. So this is a material simply can absorb the repel water, obviously, and absorbs the energy and absorbs the vibration and makes the building much more comfortable for people to live in, or much more efficient and use much less energy if you want to use this as an industrial workshop roof. So there is a trend without saying. So it's a very traditional design, and all the arrows, the blue arrows mentioned here is another benefit. It's because by prefabrication of these synthetic resin roof tiles, you can build a internal ventilation circulation tunnels, in the roof by itself. So in summer or winter, it can deliberately guide the air to go through the roof system in certain direction, by either reserve the energy within the building or by dissipating the heat from the building. All in all, to help you to make the building much more energy efficient. So, and by doing this, we actually help people to build a green building. We don't actually generate any energy or store any energy, but we help the building to use the energy as it is much more efficiently as part of the roofing system. Obviously, of course, we can use ASA to be part of the window profile or door panel profile as well. If we all use ASA on those parts, roof, window, or door, or floor, and then it can even help the building even more. So this is a summary beneath that. This is a low-cost system which can offer you to build a much greener green building system. So the first products we already talked about it, the synthetic resin roof tile or profile. This is a multi-layer system. So on the top is our ASA. In this picture, that's the red part. The green part and the white part below are usually made by PVC. So they are extremely cheap. So the main reason why people follow this structure is that PVC are very cheap, right? So you can use the cheap material to form the substrate. As you can see from the picture, they comprise for more than 90% of the tile, and then only for less than 10% of the tile, and then you can have a very good appearance of the tile, and then you can have a very good weather performance, energy saving, all these benefits you can harvest from the PVC. And the second family of the products is the same topic as we talked in the first episode, is the steel ASA or other plastic composite sheet. This type of solution is mostly used in the industrial workshop or farming facility buildings because they want a very fast deployment of the roofing system. So the metal base would offer them just that with the benefits. So it's very easy to make, it's very easy to install, it's very because on the top we make ASA as a protective film, protective cover for the composite sheet. The whole system can offer the building much more protections as well. So compared with the first one, back one slide, this synthetic roof tile, this metal ASA composite sheet are even cheaper, are even easier to be installed, and can be much more easier and quicker be replaced, when you want to. So that's just to fit many of the industrial workshop demand. This, totally synthetic resin roof tile or profile system are mostly used in the residential building. So as for all the houses or the apartment we live in, because we want more comfort, right? So, and we want more energy efficiency, and we want more, comfort either in the summer or the winter seasons. So. These are the two major directions and the major differences between the all synthetic resin solution or the metal film laminated sheet, composite sheet solution. Okay, so this is a structure, more detailed structure illustration of the metal plastic sheet solution. So usually, as showed on the chart, on the right hand side, the middle, the light blue part is the metal base, and with the matte glue, strengthened base in the middle, and on the top we can make it with our ASA, PVC, or PET, or many other solutions from Traumate technology, and then just to fulfill the needs for you to build different type of metal plastic composite sheet. So on the left hand side, I can see the three major parts of the material other than the metal based sheet. So the film at the top, the glue layer and the adhesive layer, and the matte strengthening layer in the middle to help the film to stick stronger and stable on the metal sheet. Okay, so if you have more interest, you can go back to the first episode. We'll give you a link and for a much more detailed and much more comprehensive introduction of this specific product type. Okay, so as I said, when you make a synthetic resin roof tile or profile, there are two types of production process. One is called co-extrusion process. On the left-hand side information. So usually you will have a main drive of the machine and the main extruder with the function to extrude the substrate. So if you could recall the structure of the composite roof tile, the major part is the PVC, right? So as the substrate. So this is what the main extruder does to extrude PVC through this direction, and the co-extruder handle the ASA. So we feed the ASA here, the granule here, and co-extrudes the ASA layer, into the mold, the die head at this point, and this point would combine the two stuff together and into a single multi-layer structure and got solidified in the mold. This mold actions as behave with the function that solidify and cool down the whole structure of either the roof or the window profile. So this process much more used to make window profile. So because it's just a fit the size and production type of window profile, and relatively less of using it. People use it to make a roof tile, but sometimes people do use such co-extrusion profile to use a window profile to make a roofing tile as well. So on the other hand, roofing tile are made much more by the lamination process, as shown on the right-hand side. So we didn't have a good picture unfortunately, to show the lamination part of the lamination portion of the machine. But again, you can go back to the episode 1, and there was a very detailed, illustration about how different part of the layers are laminated together. And then here we just shows the outputting die compressing molding part of the machine. So after we combine the ASA sheet over the PVC substrate together, and then through a hot compressed mold mechanism, we can compress them, mold them into the tile. So as you can see, this is a continuous, production procedure that you can have an unlimited length of this film being produced as long as you have the raw material feeding to the machine. And then you can take the sheet and cut them into the size, and the shape of what you want it, lately, to fit different type of buildings. Okay. So these are the two processes we usually use to make the synthetic resin roof tiles. And then for the lamination process for the metal sheet, composite sheet, I won't go into too much details because this was included in episode 1. There was a very detailed discussion over there. We'll just briefly talk about that. So it is a thermal lamination process. Okay, so this is the lamination part. So the metal sheet goes here, the plastic film goes here, and the strengthening glue layer usually goes into the middle. And as a later part, there is the preheat and thermal pressing module to help all these layers to come together. And then after we put everything together, again, there is a molding thermal compressed molding part of the machine to mold the composite sheet into different shapes. So as you can see, this shape is very similar to the plastic roof tile roofing shape design. This is the China style. So if you travel into China, you see the residential building roofs or the industrial building roofs. You see this type of design a lot in China, and it certainly have impact in Southeast Asia or some other countries. But in other countries, we do see very different design of the roofing texture and the shapes. So this is all can be customized and according to your needs and according to your aesthetic demand. So whatever shape you would like with your roof. Okay. Now product properties. So we talked about the synthetic resin roof tiles, right? So we talked about the composite metal plastic roof tiles, and then the common feature and the same point with these two family of products are they both have our ASA, at the top. Why? Because this ASA is the most valuable part of the two family of roof tiles because they are extremely weatherable. So as we can see, it is the most important feature of our products here. With all these different colors, with all these different texture design and size design of the ASA film, which you can put on top of PVC substrate or a steel sheet. they are extremely weatherable. So as I said, in 20 years is the norm according to the China building construction, weatherability demand. 20 years is also a very common number according to many countries' industrial standard demand. But some country does have a relatively lower demand for 15 years, and some special countries would have demand for 25 years. So, but we are confident to meet whatever the customer may ask for our weatherability or UV resistance demand. Because we are talking about weather resistance, UV is the major part of the degrading impacting factor. And beyond UV, there are also water, humidity impacts, and other long-term heat exposure impacts. So ASA are extremely stable for a lot of them. So again, it can easily sustain for over 20 years. Okay, corrosion resistance, we already talked about the water. And then in certain area, the acid rain is the big impact factor, especially when you have the industrial workshops resides in a coal mine, nearby a coal mine, or nearby an oil field, or nearby certain very harsh environment. Then the water quality, or the rain, or the dust, or the chemical residual chemicals contained in the atmosphere in the surrounding area may impact on the roof or other building materials in a building. If you choose metal, as people usually choose in many areas, it may erode through the roofing system very quickly. So in China, as we observed, with many buildings using metal solutions, in some extreme situations, the environment may eat through the whole roofing system within less than a year. So it is very harsh, and it is very inconvenient, if you would need to replace the roof for every year. So then again, with the protection of the ASA top film, we can prolong the metal sheet on the roof comfortably for over 15 or 20 years. So this corrosion resistance is another very important factor related with our products and solution. And aesthetic, we talked about that a lot. We can pre-color the film into different colors. So you can choose either a single color or combination of colors, or we can even make some visual effects, like we can make the film looks like a wood grain, or we can make the film look like natural stone. So yeah, so all in all, what the key point here is, we can talk with your designer, understand what they need with your building, and make our film available to fulfill your aesthetic demand, to make your building looks prettier. And then eco-friendly, so it's all recyclable. So either for the PVC substrate, for the metal substrate, or for the plastic cover from our ASA, it can be easily separated and recycled for the next cycle of usage. So this is another big topic and big benefits for the green topic. Okay, so now our advantage related with Chongmei. So Chongmei, as we introduced at the beginning, is a small company founded in 2008. It's a family-owned firm, but we have a very strong R&D capability within this firm because, as I introduced myself, I have nearly 30 years of R&D and industrial experience in this industry, polymer industry. And we have several other PhDs, masters, all with a long-serving industry in the polymer, long-serving experience in the polymer industry, and have lots of products and solution development experience related with many with many different applications in many areas. So pretty much when you have a demand, from many different industries or applications, as long as they are, can be concluded to be related with polymer, and pretty much, we are likely to can come up with certain solution can serve your purpose pretty well. So, this ASA product, granule or film, or all this roof tile window profile solutions, are excellent examples. So, we can go even deeper with this industry to offer very different designs to fulfill your needs. Or on the building, if you need different resins other than ASA to serve different purpose, we can still do that. Okay, so just come and talk with us, and as to explain what you would need in your application. Equipment support. Just one point to be clear at the beginning of this slide, we don't make equipment. Okay, so we make materials, we make polymer materials, but with our long industrial experience, serving in many applications, we did accumulate lots of experience about equipment. So about which type of equipment you would need to use, or what's the configuration of certain equipment you would need to set up, or when you use certain type of equipment and you run into issues, how to adjust the equipment and adjust your configurations of your equipment to solve your issues. So, being Chongmei's technology team, or being Chongmei as a firm, we actually use this as a strong value-added service we provide to our customers for free. So, so if you would need to solve certain issue related with polymer, we not only provide the polymer itself, we will not only provide a consulting opinion related with polymer, we also offer this equipment related service to you for free. So, customization capability, we had touched that point a lot in the previous part of the presentation, that, just please come to us and present what you would need. Okay, so you would need certain solution on building. You would need one certain special solution on your cars, or your equipment, or your other appliance or furnitures. As long as it's related with polymer, we can customize that, by talking with you, understand your design, and offer our opinion and design to you. Not only about the polymer material, but also about how to make it, how to acquire the equipment, how to choose the equipment, how to set up the equipment. Integrated service is more or less the same point. We have a very strong presence in China. We have a wide and strong presence in many regions across the globe as well. Although we are very small, but we have a quite broad and strong presence in certain regions in the world. So, So again, come to us and bring your issues or bring your market demands to us, and we'll come back to you with good solutions. Related with polymer. And global experience. So this is a point we touched again. We do have a broad and strong presence, in many regions as well. Markets and customers. We have a very strong presence in China, as I said. So we started our business in 2008. Right now, we are actually, one of the top 3 players for the roof tile window profile related granules and weatherable granules and film producers in all of China. So that's quite a impressive achievement in China if you understood how competitive the China market is. And we do have a broad and strong presence in Southeast Asia, in Middle East, in India, Indonesia, part of Africa, and part of South America. So we do have small business in Europe and North America as well. But until now, these two regions are not the most strong, or not the strongest presence we have so far. But we want to go deeper into these two regions as well. But all in all, what we want to say is we do have both local and multi-international experience in the polymer industry. Okay, so this can represent lots of values to our customers, as we demonstrate in the past, or we can offer all this experience related with China market and international market to our new customers in the future. Okay, so these are some of the Chinese and international customers we serve in the PNC market. So yeah, so you can see some prominent names over there. So through our long service time, in the past almost 20 years, and then we have quite some successful business stories over there. Okay, so yeah, I won't read all these points, but I just emphasize the key point here of the presentation today. We are a specialized polymer solution and product provider, and we have a strong technology. We have a strong technology capability and a strong production capability in the polymer related industry. So right now, the biggest product portfolio we have are the ASA granules and ASA films and the XETFE ASA products for the building and construction, green building applications, XETFE for aerospace wire and cable, and other products for medical care and other high-end applications. Okay. So, okay, I think this is the last slides I have, and then this concludes my presentation. I'll go into the Q&A session.
Thank you very much, Dr. Shang. Interesting presentation. Thank you very much. Guys, it's a time to ask some questions on this subject today. If you have any questions, please post the question in the question box. Actually, Dr. Shang, there are a couple of questions already. Let me show you on the screen.
Okay. Did you show any questions? I don't see anything.
I'm going to just a second. Just I'm setting up for you.
Okay.
Please stand by.
All right. Okay, thank you. Thank you, Param. So the first question is, what are the key challenges in processing or compounding ASA materials for large-scale building applications? Okay, so relatively speaking, ASA is a kind of polymer easy to process. So you can process ASA at a relatively moderate temperature, that's residing in 250 to 280 degree Celsius degrees C range. So it's not too high or too low, quite comfortable for a polymer processing, and it's relatively easy to compound them. So it's behave moderately easy to be handled within a twin screw extruder. So by processing ASA itself, it's relatively easy. But that's not saying everyone can doing that, because the design of ASA formulation is somewhat tricky. So as I explained, ASA is a tri-block copolymer, right? So there is a complex point related with polymer that you need to blend two parts of the polymer together. One is the so-called ASA rubber. So this is tri-block ASA rubber phase to be blended with a SAN resin. So, and while at the same time, you need to introduce pigments to make the color right, and you need to introduce all the additive to make the resin stable, and you need to introduce certain specialty additive to fulfill the specialty demand from the customer. So the formulation design itself is somewhat tricky. So you would need to have the industrial experience and formulation design experience to make everything right. The color right, the function right, and the pellet size, shape, this everything right. So that represents the biggest challenge for the ASA resin. So once you have that correct, and then handle ASA pellets on a or in a extruder is relatively simple. Okay. So the second question is, how can color stability and surface finish of ASA be maintained over a long period under outdoor exposure? So this is an excellent question. Thank you for asking that. And then as I explained, the nature of ASA resin is a very stable resin. Okay, so this combination of acrylonitrile, styrene, and butyl acrylic resin is a stable combination to guarantee the resin can sustain the exposure of UV, water erosion, and other chemical erosion through a long exposure outdoor, or even in some very harsh environments, like right on the equator environment, which have very long and harsh exposure to the UV from the sunshine all year long. Okay, so this basic nature of ASA guarantee it has a strong backbone to sustain the UV exposure, but the backbone itself is not sufficient. So then within the formulation design, we would need to make several type of choices to make ASA even stronger. So number one, you would need to choose a very smart and precise additive package to help the ASA to sustain the UV exposure even better. So that's number one. So combine with ASA resin to make it even stronger, and then to choose the right pigment package and pigment combination design, and then to choose the right pigments that can sustain a very long time through the exposure under UV. And number three, you will also need to distribute the additive and the pigments and whatever other additive you would use to into the ASA resin evenly and uniformly. That makes the performance even better. So these three are the most important techniques you can apply to help the ASA compound sustain to UV exposure for over 20 years. Of course, other than the ASA resin itself, it's the nature of the material. The other two, number two and then number three, both require technical capability and experience to design a appropriate ASA formulation. And there's a number four technique you can apply, in special circumstances. So when you make the ASA into an article, you can add another transparent layer on top of ASA layer. of the ASA sheet. So you can either apply the coating technique, or you can apply the cold extrusion or lamination technique to apply another transparent layer on top of ASA. That would offer another additional protection feature to the whole article to help the article to sustain a longer time. Okay, so these are the major things we can apply. The third question is, what future innovations or research areas could further enhance the sustainability and performance of a composite? Okay, excellent question. Thank you. So in my mind, and more or less in our team's mind, there are several things you can do. Number one is to make ASA even more weatherable. So there are research activities ongoing, within the industry, to improve the emulsion polymerization process to make the ASA backbone even more stronger against the UV, right? So that's one thing. The other thing is in the formulation design step, I just said, in responding to the second question, that you would need to choose a smart additive package, right? So the smart means there are lots of different combinations and different choices of the additives, and then to find and apply the smarter additive, right? So the even better additive package that we can design to help the ASA to sustain even longer. So by offering the material even longer service lifetime span, and then we can help the sustainability a lot. So these two are obviously to make some obviously options. And on top of that, we can also try to introduce non-coal or non-crude oil originated materials into the ASA solution to make the whole solution more eco-friendly. So there is a very strong trend in the ASA board, when they used in the floorboard or the park rails or the park board applications to introduce bamboo or wood grain or wood particles into the composites. So that is one solution people would use, and then. But when you're doing that, the overall performance are sacrificed a little bit. So by improving the technology, when we can introduce more natural recyclable material into the ASA compounding, but we can still maintain a very good ASA overall performance, or even better ASA performance, so we can help the sustainability topic as well. So. Okay, so I think these are the major trends related with the innovation for even further, even better sustainability performance. Okay, next question is, can sustainability and beauty truly coexist, or do they sometimes conflict in building design? Yes, unfortunately, yes. So usually when we are talking about sustainability and beauty, usually they conflict in one or more than one aspects. So the very common dilemma we run into is that when we want the building to look better, when we want a better appearance of the building, we would need to apply certain materials that are not so sustainable. So, but that's not the only direction or the only answer to this kind of dilemmas. We just talked about the pretty good solution that can combine the sustainability and beauty together today, right? So we can use PVC substrate, which is very cheap, recyclable, and apply a very thin layer of ASA on top of it, and make the whole solution fulfilling the aesthetic performance really well, while at the same time fulfill the sustainability performance pretty well. So there is the middle ground that we can apply the technique, and we can help people to push these two sides of the demand to the middle and fulfill two things together. So it may not be perfect. So we fulfill 100% of the sustainability demand and 100% of the beauty demand all at the same time. But we can help to push the bar higher and higher. So again, the ASA type of synthetic resin roof tiles and steel ASA roof tiles are excellent examples that we can help to help these two things together. And in the future episode, we're going to talk about another novel thermal insulation solutions, which is another excellent solution as well. So we can help to combine the thermal insulation layer of the building and an excellent aesthetic surface layer combination, and put these two things together. Okay, so there is a way. Although we may never reach 100% of both things together at the same time. Okay, the question says, looking ahead, how can we make eco-aesthetics not just a design trend, but a core mindset for sustainable urban development? So this is excellent question again. So from, I am an engineer, right? So our Chongmei Technology is a company offering materials and offering polymeric solutions to the industry. So, but in many actual scenarios, we did talk with the designer of the building. So we did talk with them when they choose the color, when they choose the outer appearance of the building, and then we can give them recommendations. So, one core challenge we very often run into was that, I want to be sustainable, but how can you make sure I make this building pretty enough to attract our customer to buy the building from us? And then that represents a very solid and very authentic question to us that, how we can make this technique available to our customers, that they can truly make this good looking roof tiles or window profiles or the thermal insulation solutions, while at the same time, we can embed the sustainable technique inside the solution. So this burden is actually on the polymeric material and other building and construction materials providers' shoulders, that to provide those good sustainable solution and with the good appearance at the same time. So at least part of the burdens are on our shoulders, and we're not shy to take it. Again, this ASA related solutions, the granules, the films, the composite sheets are excellent examples. So we actually had done some really impressive job in the past, and we are very proud of it. So again, we are a small family-owned business. We have a very small team, but we are extremely proud of the work we have done in the past 20 years. Okay, so this is one way to do it, to push this sustainable mentality and mentality into people's mind by offering the truly performing technique and products. Okay, next question says, what are the key molecule or structural features of ASA, acrylonitrile, styrene, acrylate that give it superior weathability compared to ABS and PVC? Okay, very technical and excellent question. Okay, to answer this or to understand this, firstly, you would need to understand why ABS and PVC are not resistant to weathability, to UV exposure. Okay, so in the structure of ABS, the A is again represent for acrylonitrile, B represent for butadiene, and S again represent for styrene. So except for acrylonitrile, which is reasonably good resistance to UV exposure, both butadiene and styrene are very bad, against the UV exposure. So especially with the B in the middle of ABS, butadiene copolymer is a very, very bad copolymer resisting to UV. So once you expose ABS to UV environments, UV light can penetrate inside the material and break down the butadiene part of ASA very quickly. So that's why the ABS resin turns yellow and losing its properties a long time if you expose it to the UV light for too long. And the PVC has a similar story. So the PVC represents for polyvinyl chloride. So so its monomer is ethylene chloride. So the ethylene chloride, the ethylene itself, the polyethylene itself is strong enough against the UV, but unfortunately it has a chloride alongside with it. So it's like a big burden alongside on its wagon. When you expose PVC to UV light or to water, and then the chloride part of the chloride part alongside the polyethylene backbone chain are very happy to absorb the UV light and start to react, and the reaction is bad. Right? So with polymer, you don't want the polymer to react with anything. You want the polymer to don't react to anything and stay stable and stay inert to anything. So once it starts to react, it starts to break down, to turn yellow, to turn into powders, and all these bad things start to happen. And then that's what the chloride does. It would absorb the UV light and react with the backbone and break down the backbone into powders. So to resolve all these issues, you would need to do exactly the opposite. So you take an ABS, you take out the butadiene and replace it with another rubber. So butadiene copolymer behaves like a rubber inside ABS to give the impact resistance performance, and then you take it out and replace it with acrylic rubber. So acrylic rubber is much more resistant to UV. So that's why. So that's a fundamental understanding of why ASA is so stable. So that's academic understanding. Of course, there are lots of other nuances, to truly make the ASA right. Okay. I hope that answers this question. Okay, the next one says, what additives or stabilizers are most critical in ASA composite formulations to enhance durability and color retention? Okay, another excellent question. So the usual additive package includes the thermal stability, the thermal stabilizers, and the light stabilizers. The thermal stabilizers, behave as the proxy to help the ASA to sustain the high temperature history through the processing. When you process ASA, the resin need to go through temperature up to 280 degrees C for a few times. So it need to survive such history, then you would need the thermal stabilizers. And then you also need the light stabilizers, right? So because you will need to expose the resin under UV environment, and you would need the stabilizer to help the resin to cope with the UV light and other light, blue light, the purple light, green light, in the visible light range as well. So there is a group of additives called light stabilizers, and there is also this other type of stabilizers to help with, the anti-degradation additives you would need to use to help the ASA cope with the corrosive environment as well. So the thermal and light stabilizers family also play the same role for the pigments, but of course, you need to choose different type of additives for the pigments other than for the resin, which makes the whole design much more complex, overall. So yeah, so theoretically speaking, these three families of additives are the additives you need to choose, but of course, the individual additives, what brand, how the amount, the combination, are kind of a mixture of science and art to achieve in the formulation design. Okay, next one says, can ASA films be thermoformed or vacuum formed or post lamination without losing mechanical or optical properties? The simple answer is yes. So ASA film usually is thermoformed, during the lamination process. So when you have to apply the glue or the intermediate strengthening layer onto the ASA film and apply them on either PVC substrate or the steel substrate. And when you compress, mold it into different shape, it's a typical thermoforming process. Okay, so it's thermoformed. And it can certainly be vacuum formed, but during the vacuum formed process, you need to preheat the film to a certain temperature. Usually, you need to heat it up to well above 200 degrees C. So to help the film to stick on the surface of your substrate well enough. This thermoforming or vacuum forming compressed forming process doesn't impact the mechanical or optical property at all. So you don't need to worry about that at all. Okay. One very quick point back to the previous question. That of course, you need to design the ASA granule or the ASA film, appropriately to guarantee that. So it is not a granted point that you just take ASA, not any ASA film, you thermoforming them, you vacuum forming them, vacuum compress molding them, and maintain the same thermal and optical property. You need appropriate design of the ASA film to do that. But once you achieve that point, you don't need to worry about that at all. Okay, going next. This one says, are there any efforts towards developing bio-based or recyclable ASA film for green construction markets? The simple answer is no, not yet. And the reason behind that is very simple. Because we talk about the monomers of ASA, right? So acrylonitrile, styrene, and acrylic. Not any of these three monomers has a sensible or economic, financially viable source of monomer source. So for acrylic, butyl acrylic rubber phase is possible to derive that from bio-sourced or recycle-sourced, material, but it's simply way more expensive than the oil-based butyl acrylic source. So, yeah, it's not financially viable to make it a bio-based ASA yet in the foreseeable future. So based on my experience, if I, understand it correctly, it will take at least 15, 20 years to make a truly bio-based, ASA. But on the other hand, recyclable ASA is very simple. So right now, as I said in the presentation, the eco-friendliness of our ASA solution is a strong point with our products and solution because you can easily recycle it. You can just take the material when the roof serves the life span. You can simply take it out and grind it into powders, and then put it back into a new wave of roof production in the metal, steel, ASA composite film sheet scenario. You can simply separate them. It's a relatively easy procedure. You can simply separate them, and recycle the plastic part and the steel part, and to different recycle streams. So yeah, so no to the bio-based for now, and very easy for the recyclable ASA. Okay, next one. Do you have experience with solar roof tiles? Yes, we do. Yeah, so solar roof tiles is a very broad topic. Obviously, you can reach out to us yeah, to explain what exactly you would need with the solar roof tiles, and then we can discuss from there.
Okay, that's all the questions we have, Dr. Shang. Thank you very much. Thank you for doing a presentation and addressing all the questions.
Prem. So one more point. So is there a way the audience can reach out to us through you, either through you or through this?
Yes, so if there are any questions, they can reach out to me. But you can always put on the last slide, your email address next time. Okay, so that they can find that.
Yeah, so
Yeah.
we forgot doing that.
Would you like to give it?
Yeah, so that's why I asked, and yeah, so that's why they can reach out to you, and you can put us in contact, with the discussion.
Sure. Okay. Yeah. Could you like to give a final message to the audience?
Yeah, thank you, Perryman. Thank you for everyone listening to this presentation. It's a very pleasant experience, and I just like to emphasize that we are a specialized polymer solution provider, so we can discuss about your demand and give you the polymer solution. And then we can also offer the free service about the equipment, about your total solution, and reach out to us and have a discussion. Thank you.
Thank you. Thank you very much, Dr. Shang. Thank you very much.
Thank you.
Guys, so that's the end of the session today of the Techno-based Polyglory Tech Talk, and the topic on the eco-aesthetics, ASA Composite Shingles, driving in new trends in green building. It's a really interesting presentation. I'm hoping that you find this session useful. That's Dr. Shang, Chief Technology Officer at Xingjiang Zhongmei Technology. If you need more information, you can write to him or write to us so we can communicate with them. Thank you all for joining this session today. Look forward to welcome you in the next episode of the Techno-based Polymer Tech Talk. Thank you. Bye-bye for now.